Unix has a program called sort that can sort the content of a text file by redirecting it to standard in. So for example, here is the text file, just some paragraph from a novel. And if we sort that, then the lines are basically sorted. So first the uppercase characters F and T, and then the lowercase characters from A to W. Okay, and today I want to look at two implementations of this program in C++ and C to compare them. Okay, so let's start with the C++ version. Here we have a vector of string for all our lines because we need to read them into memory before we can sort them. Then a string for a single line, the current line that we want to read in. And then we call the getLine function to say we want to get from standard in the current line. And while that works, the line is pushed back into the vector. Okay, then all the lines are in memory. Then we can sort them by passing the begin and end iterator into the standard sort algorithm. And finally, with a for each loop for each line and lines, we print the lines to the terminal. Okay, cool. Now let's compare that with the C version. Let me split that to the right so we can see both versions. Okay, so of course C doesn't have vectors or strings. Here I just use a fixed size array of char pointers, so my program can only handle at most 10,000 lines. Okay, and how many of those 10,000 lines are used so far? Initially, of course, that is 0. Okay, then yeah, we don't have strings, so let's just use 1,000 characters. Hopefully no line will be longer than that. And then the while loop looks rather similar. We call fgets. This is the buffer where we want to store. This is the size of the buffer. We have to pass that explicitly because arrays decay to pointers when we pass them to functions. And finally, we want to read from standard in. Okay, and then unfortunately, fgets will store the new line character at the end of the string if there is one. So we check for that and then replace that with the null terminator. And you may think, why do I even check for that if that should always happen? Well, if we have lines longer than 1,000 characters, let's say 1,500, then in one iteration we will get 1,000 lines without the new line, and then in the next iteration we will get 500 characters with the new line. Okay, and then finally we have to push the line back into lines. How do we do that? We allocate enough memory for the payload and the null terminator, store that at the next available slot, and then increment used. Okay, yeah, and then we copy the line into that. Quite a compact line. Maybe you would split that into 2 lines in the real world. Okay, then we have that in memory. How would we sort? We call the qsort function. It expects the array, the number of elements to be sorted, and the size of all the elements, which are char pointers in our case. Okay, and then a custom compare function, which always looks like this. It takes 2 const void pointers to 2 elements in the array, and we have to decide via -0 or positive number if the first element is less than equal to or greater than the second element. Okay, and finally, instead of for each, we have a classic counting loop. So all the numbers less than used, and then we print the current line, and then we free it, because every malloc call that happens at runtime must be matched by a free call happening at runtime. Otherwise, we get a memory leak. Okay, since the program ends after this loop, maybe it wouldn't be so critical here to actually perform the free. But in longer running programs, memory leaks are a big issue. Okay, so does this actually work? Maybe let's try that. I have my sort C here with para. Yeah, that seems to give us the exact same output. And instead of a paragraph, let's sort an entire book. Then we get a segmentation for it because the book has more than 10,000 lines. Does it work with the C++ version? Yeah, that works. So these quoting characters seem to come quite late in our character set. But here we have from O to Y, and then it starts again at B because these quoting characters are obviously different, right? Unicode with all its quoting characters. Okay, what would happen if the free call comes before the printf? That is undefined behavior. You can't use lines I after freeing it, but of course we can try. So I prepared that as well. That would be dangling, and let's do it with a para so it's more obvious. Then we get some normal lines interspersed with lots of garbage, and if we do it again, then we get different garbage. So it's non-deterministic what happens if you use memory after freeing it. That's called a use after free bug. Okay, and interestingly, in the C++ version, we have neither malloc nor free, so the dynamic memory is managed by string and by vector, and when these variables go out of scope, the memory is released automatically. That's arguably the most important feature of C++. Has nothing to do with garbage collection, it's completely deterministic. And if we wanted to release the dynamic memory handled by line sooner, because after the while we don't really need this variable anymore, we could simply introduce another scope here, like this, and then for beauty, let's indent it, and then the line destructor would run here, releasing the managed memory. So I think that's pretty cool. It doesn't only work for memory, it also works for file handles and database connections and such. Again, probably the most important C++ feature. Okay, yes, I didn't show you the string compare yet. So how does that work? String compare takes two const void pointers to two elements, and we can't, what we actually want to do is delegate to strcomp, but strcomp expects the char pointers themselves, not pointers to them, and that's why we have to cast the const void pointers to const char pointer, const pointer, and dereference to get one step closer to the actual const char pointers. So this is very highly idiomatic C code. You would never write something like this in C++. But you could. The compiler would accept it, but probably not your senior during a code review. Okay, so I definitely don't want to hate on C. I just want to show you C++ code tends to be more high level, more stuff managed for you behind the back. And whereas C code tends to be more low level, every step is very explicit, the memory management is explicit, and you will never get magic at closing braces or something like this. Or let's say magic object copies. For example, in the C++ code, if you remove the ampersands here, then line will no longer be the original inside lines, but a copy. And maybe that's not obvious to a C programmer that this will perform a copy. So every language has its pros and cons, of course.